This meeting is being recorded.
Hello, everyone, and welcome here. We're 14 from now. Maybe we'll wait a couple of minutes while everyone is joining. Or maybe we start considering the webinar is recorded. Anyone can catch up. So, hello, everyone. Nice to meet you. My name is Manon. I'm part of the Open Food Fact team. And we are super excited to have this meeting today, this webinar, because it's the first time that we have a webinar dedicated to the research community. So thank you very much for joining. For a few years now, we've seen that researchers have been using Open Food Facts in many different ways for studies around nutrition, around health impact, but also sustainability impact of food. And finally, we are creating this space to connect with all researchers and students who are working with our data so that we can better help you, better support your work and answer all your questions. As we said, we are recording this webinar, so we will send the recording by the end of this week. Thank you everyone for muting your microphone. This is super helpful. And as we are probably going to be more than 20, we won't have time to do a big round table. So we've prepared a little document where everyone can introduce themselves. I'm going to share this document in the chat. Up. You should see the link in the chat. And hopefully, if you'd like to connect, feel free to put your name and maybe LinkedIn as well, so we can keep in touch after the event. And there's a second part in the document for questions, so we can gather the question in the document rather than the chat, so it'll be a bit easier to deal with them afterwards. So, next slide, please, Charles. The program. So we have an hour together. We will give you a quick overview of what Open Food Facts is, what we do, and why. Then we'll dive into the data. So what kind of information we collect, in what quantity, how it's being used by research projects. And then we will present you the Open Food Facts for Science program, which is fairly new initiative that we created to better support the researchers. And then we'll have the Q&A session. Hopefully we'll be fast enough so we have a lot of time to discuss together. Next. So let's start with Open Food Facts and why it all started. Maybe some of you already know all that, but today there is over 1 billion people around the world that are considered obese. And in Europe, it's 1 in 3 children that is affected. And so the challenge is that things are getting worse. In 2035, it'll be about half of the world population that could be living with obesity. And there's also a major impact on sustainability. The food represents about a third of greenhouse gases. So it's time to take action. Many consumers are wanting to take action, want to make healthier choices, more sustainable choices, but it could be quite difficult to find the information. We all know how difficult it can be to read little ingredient lists or understand additives or labels. They can be quite difficult to grasp. So there's definitely a real need for a clearer and more accessible information around food. And this is why open food facts come in. Next slide, please, Charles. So who are we? For those that don't know us, I see in the chat there's a few names that rings a bell. But for those that don't know us, we are a collaborative, open database of food products. And we've been building this database since 2012. We're a non-profit organization, so strictly independent from the food industry regarding fundings. And we're very proud to be recognized as one of the United Nations digital public good. And what is really core to the Open Food Fact project is that we are a community-driven model. We've got contributors from all over the world who are helping us grow and improve the database. And everything we do, it's in our name basically. It's open source and open data because we believe that food knowledge should be accessible and reusable by everyone. Next.
Thank you, Mano. I take the point.
Okay.
So our mission is that we seek to empower people. Empowering people is not just the general public. It's also, of course, it's consumers, but it's also producers, researchers, governments, and so on, journalists. We want to make data at the center of the debate, and we want to empower the debate, the discussions, the studies, and things like that with this data. So this data, we think that it will achieve measurements and change at large scale and change the impact of food on our health and on the planet. So we have made this little graph to try to explain what we call a kind of a virtuous circle of food transparency. First, there is data, and open and reusable data. And then this is building usages, like scientific usages. And these usages are building, are also allowing awareness, enlightenment with better informed users and food producers, and also scientists, of course. And then this is also leading to commitment with more engaged community of contributors, and it also raised awareness again. And then this leads to more data. This circle at the end is leading to, we think, healthier products with a lower environmental impact. Because where all the people are more enlightened by the usages, by the data, by the studies, by journalist articles, things like that, we think that it will lead to better products. A few figures about what we have already done. We have reached nearly 4 million products from all over the world, available in more than 40 languages. I'm sorry. with 80,000 contributors also all around the world. We also have conversation with producers, because we are not fighting producers, we are not fighting the industry, we are fighting for transparency. Okay, and so we used to talk with producers, and they now more and more engage with us and sharing data with us. And so we have now 350 producers sharing their data with us, thanks to a specific platform. We'll talk about it later. We have made a little study to list all the scientific papers mentioning citing open food facts. There are more than 600, but we'll be talking about this later. And nearly 4 million unique visitors monthly. This is mainly from the general public. So what kind of data are we talking about? Firstly, we are talking about raw data. In fact, it's anything that you can see on a packaged food. You see when you are opening something, you can read many things. Of course, ingredients, nutritional facts, prices, also packaging codes, and many things. For some operations, for example, we even wanted to weight the products, and so we have a micro. I don't know the term in English. I think it's balances. No, it's not correct.
Scale.
Yeah, and so everything we can gather through a simple operation, just reading things or things like that, we can add it in the database. So in total, we have more than 150 raw data filled into the database. And we are also computing data. Of course, we used to compute the Nutri-Score, which is very popular here in Europe. Maybe American people right here don't know well this kind of front of pack from front of pack label, but it's very popular here in Europe because it has been adopted by 7 countries. We have launched ourselves the Green Score with other partners, which is measuring environmental impact of food products. Of course, we're also displaying the computing and displaying the Nova Group, which you might know from a Brazilian research Professor Monteiro. Of course, ingredient list analysis with the automatic extraction of the additives. We are able to tell if product is vegetarian or not, vegan or not, if it contains palm and things like that. So many data are also computed directly from the raw data, and we are of course adding this to the database and displaying it in our tools. So how much data are we talking about? I said previously that we were keen to about 4 million products. We gather more than 1,500 products per day. It's more or less, of course, but I think we will reach more than 500,000 products this year, um, in addition to this one, those one, and we have scored more than 1.3 million products with the Nutri-Score, about 1 million products with the Green Score and the Nova. Here you can see also a graph with the repartition in all the countries where we have all data. Of course, France is still a big country because we started in France. So that's why that explain why we have so much products in France. The United States then is coming in second, thanks to the USDA database, which is also open data and which we are importing into Open Food Facts. Thanks a lot for them and for this. And then many European countries, as you can see there. Manon?
Yes, I think there's a little lag in the change of slide.
Oh, sorry.
So yes, on top of all this data that Charles mentioned, we also have a bit more than 8 million images. So these are photos either of the front of pack or a photo of the ingredient list, photo of the nutritional table. All this information are super valuable, and this image collection is basically very reusable for training AI or machine learning models. We do it already today. The Open Food Facts, we extract text from images to get ingredient list, for example. We can also detect logos of brands or logo of labels to extract information and enrich our product sheets. And it could also be used to analyze product claims, for example. And yes, just like everything else in Open Food Fact, this is open data and reusable by everyone. Now let's talk about how Open Food Fact is being reused in research, the topic of our webinar today. So on the left, we've put a little table which assess the level of involvement of Open Food Facts in different research studies. So we can see that in at least 17 studies, Open Food Facts was the essential data set. So the study couldn't have been made without Open Food Facts. And again, for 21 study, it's been considered as an important source. So I think it's fair to say that for almost 40 study, if we make the sum of these two, Open Food Fact was of major importance in the research study. And then we've also identified a bit more than 400 research that are mentioning Open Food Facts, but the full usage of Open Food Fact is still unknown because it would take a lot of time to analyze and do this work. And on the right of this image, we have two examples of how our database can be used. So first, our impact with the Nutri-Score, where we were involved in the phase of testing of this Nutri-Score index. So the idea was to confront the theoretical methodology of the score. So confront it to millions of products in order to see if the results were homogeneous or not, and that we wouldn't end up with a 90% of Nutri-Score A or 90% of Nutri-Score E, but rather have something harmonious. And also I mentioned in the Nova study, like Charles mentioned earlier. Next slide. Yes, and two other impactful study. So the first one was EREN, which is the research team on epidemiology in France. So since 2009, sorry, they're working with a very big cohort of 170,000 participants, and they are studying their eating habits and their health condition. So they can draw a conclusion and find correlations. So in this case, they use Open Food Facts in order to have more detailed information about the food products that are being consumed by the participants. So they're very interested in ingredient lists, in the presence of additive, but also the nutritional table. This is all data that they can then analyze. And in this context, they found out that certain emulsifying additives were associated with an increased risk of cancer. So this is quite a groundbreaking study. So we're very proud to be part of this this kind of impact. And another study by the Meniketi Lab in the United States this time, where they are working on training a machine learning model in order to predict the level of ultra processing of food. And in this case, they use Open Food Facts to test the model. So quite interesting. And these are only very few examples. It's very hard work to track everything, but we made the fun exercise to type Open Food Facts on Google Scholar, and this is returning a bit more than 800 results. So some study where we are mentioned, and some where we have an essential role in the study. So this is really encouraging for the team and for the community to see that we can accelerate the progress. And our impact is interested. Many organizations are interested by our work. This is a non-exhaustive map of all the partners that we are engaging with worldwide. So we're talking with universities, with public health agencies, with consumer association as well. Turns out there's many people interested in food data. So if you're also interested, we're here to help. So let's collaborate together.
So now we are getting to the third part of this webinar. It's about the Open Food Facts for Science program. First of all, we already have many data and tools accessible on the shelf. And these tools are very interesting. We guess that it's very interesting for scientists. For example, one of the most interesting thing I think for you is the facets of the website. You can navigate through facets. If you go to on the homepage, for example, of the website, you will see this button, which is displayed at the upper right screen of the screen, and you will be able to explore products by many different facets. In these facets, there are countries, categories, brands, labels, ingredients, and you can combine these facets. And when you combine this facet, you are able to refine the data and to observe interesting phenomena. Also, we have many different exports. We have MongoDB, JSON-L, CSV, and Parquet exports, which you can find on the data page. You will be able, of course, we will share the presentation after the meeting, and you will be able to click on the link, on the links which are all over the presentation to see all the different services or things that we are talking about. We also have a tool called Mirabel for complex queries and to build your own data sets thanks to SQL language. Also, you can filter the products to avoid data quality errors because we are identifying data quality errors. Of course, it's not possible to fix all the data quality errors in a few days. So there are always in such a database, there are always data quality errors, less than 3%, but there are data quality errors. And we have more than 218 control checks available, and you can throw away these products with data quality error to use products which are more clean. Okay. We also have things that completeness indicator, quick graphs, and we have a partnership with Hugging Face, which are publishing our daily Parquet export and allowing you to play Python or R script and things like that. Of course, for all these tools, we can give a kind of a support. Of course, we can't we can't provide days of support for your project, but if it's a few hours, of course, we are always pleased to discuss with you, to listen to your issues, your problems, and so we can support you in your studies. It's always a pleasure for us. I'm sorry. Okay. And the second part of tools accessible on the shelf is about algorithm and contents, which are all, of course, open source and open contents. All what is coded for a project is published as open source and immediately available for all purposes and projects. So when one of the projects we are involved to is producing new features, they are immediately available for all the people using our platforms. That's very interesting because we are, with many different projects, we are building something that is always better and better through the time. We have a huge amount of documentation with more than 3,000 pages wiki, tech documentation, of course, tutorials and code snippets are also available. And I can tell you you can have a look to our reusing our data guide, which provide many ways to reuse our data with a code example and things like that. Of course, we also have an API. So if you need data in real time, or if you need history of some products, you can get it through the API. The API is not so much used by scientists, but it can be interesting if you have to conduct a specific kind of studies. Of course, we also have SDKs. So, for example, if you have an app to collect data, you can use our SDK to interact with open data, with Open Food Facts API or Open Food Facts data. And we also have a machine learning algorithm to complete contributors' data. And of course, all the models are available in open source, for example, for the category prediction. Manon?
Yes. So another advantage to join the program is to leverage the community of Open Food Facts. So we have 30,000 plus contributors all over the world, and many digital tools to allow everyone to interact. So first we're using Slack as community tool. And in this Slack, we have the science channel, which in which you can join and connect with other researchers, exchange ideas or ask questions. Also, very soon we're going to launch some science webinar. So they'll be happening regularly, where we'll invite researchers, and the researchers will share their work, share some insight about what they're working on with the data of Open Food Facts. Another way to leverage the community is to publish your own data. So, for example, the list of products you're studying, you can upload them to Open Food Facts, and therefore you will benefit from the community contribution. So the community can help you with the data completion, correction, etc. And you can also organize some special operations by collecting data on a specific topic. I put an example, if you'd like to click the link later, about a specific operation about packaging, the one that Charles was talking about earlier, where we collected a lot of data. And so this is all you can benefit from. But there's also a way to give back, and this time to contribute as a researcher, contribute to the project. So you can enrich the database by adding the data that you've collected for your research, adding new products. There's also many opportunities in improving our taxonomies. We've got several taxonomy of ingredients, of labels, of categories, of brands now. You can also encourage students to contribute as a class project. There's some successful example in Canada, for example. And organizing a scan party is similar than what I was mentioning earlier. It's basically fostering or encouraging citizen or people to go in a supermarket and collect data together using smartphone. So it's a fun time guaranteed. And the other way that you can contribute is by giving us some feedback and talking to us. We do some testimonial through blog posts where we can showcase your study. Would be happy to hear about your experience of data reuse through a webinar as well. The other point that Charles will explain you in the next slide, but you can also fill our directory form in order to help us identify all the studies that are reusing Open Food Facts, and just contact us directly if you have any feedback or need specific help.
So this is the directory of studies that you were talking about, Manon. For the moment, it's still a private spreadsheet. We try there to list all the studies that have been reusing Open Food Facts, and then we will achieve a nice public directory to promote all the nice studies reusing our data. So don't hesitate to mention your studies, to send us details about your studies, or even if you know some studies that are not in the list, don't hesitate to tell. So one thing that is very important is that we are also love to participate to research projects, and of course, you know that a research project is very time consuming. Generally, it takes some months to achieve, and so we really like to help, and we think that there are opportunities to seek funds with you. Currently, we are involved in 6 research projects, mainly European projects, but we hope to change that also. I have list in this slide all the projects that we are currently participating in. You can see Divine Food, Future, Nutricide, Food Contact. So with big research team or consortia, and these projects are very interesting for us because it helps us to build a new feature, to understand how the scientists can benefit from our data and from our tools. So we are very, very open to collaborate. Um, we have not just one topic of interest, not just health, but also, the environmental impact. Also, topics such as citizen science. We have conducted in the past some research projects also focusing on citizen science and how citizens can produce science, but also machine learning, education, public policies, and so on. All these kind of topics are interesting us. So this is now our vision for what's to be done next. It's maybe a kind of a roadmap, but we don't know yet what we will really do. But it's interesting for you, I guess, to understand where we would like to go in the next few years. First of all, in the Open Food Facts for Science program, we want to build a set of processes and tools to facilitate the reuse of our data and our tools for scientific research. Um, on the left, you can see 4 level: collect data, fix, enrich, and extract data. And for all these 4 level, you can see initiatives, tools, or features that we would like to develop. Maybe I won't go into the details because there are many suggestions here. But you can see, for example, in the collect part, we would like to propose custom features in our mobile app, custom features dedicated to research needs. Um, it's not impossible, and it can be done with the research team, and to try to get more and more data and more citizen data with the app. Also, we want to better clean, detect, of course, incorrect data and clean it. Also, we want to identify outliers and exceptional values to help you make better statistics, for example. Also, more and more computed scores and data. Here we are listing many possibilities. For example, the front of package nutrition symbols from Canada, or the nutrition info box in the USA, which is a proposal of the USDA, or the black octagons from Latin America, and so on. Also, we want to develop more interoperability with more databases. Today, we have integrations with SQL, Agribalize, Eurocode 2, and so on. And tomorrow, we would like to have more interoperability, sorry, with Foundation Foods from the USDA or FoodX2 from the EFSA, Ocali, and so on. So that's the first part of what we would like to achieve. And there's another, the next part is about platforms. You know the Open Food Facts platforms, but you might not know the Pro platform. The Pro platform is a platform dedicated to producers when they can publish their own products. We would like to build such a platform, but for scientists. It would be a personalized and a private platform for each research team or each researcher, enabling to take advantage of all the Open Food Facts tools. Data storage, of course, but control and cleaning, calculated data, machine learning, downloads, and so on. Here at the top right, you can see a screenshot of the already existing Pro platform dedicated for the producers, but it could be something similar for the scientists. A second platform that would be very interesting is about tracking the evolution of products. For the moment, we are, in fact, all the products that we are gathering data from are historized. But this data can't be requested with simple tools due to the architecture of the application. So we want to build separated platform allowing firstly to identify the markers of product evolution, such as nutrition, ingredients, scores, and things like that, and then allow monitoring evolution of the products with, again, facets, graphs, and so on. So that are two important projects. It won't be done in weeks, neither in months, but it would be probably a bit long to achieve that. But that's something that we want to do in the next few years.
And regarding some other things that are next, we have another exciting project that is open prices. Maybe some of you know about it. It was launched last year by the community. And only in 1 year, we have collected a bit more than 100,000 price data points worldwide. You can see the map. There's not a single continent without a price. So the goal here is to bring transparency to more on the food affordability topic, and also food access, because we can know where the products are scanned. And we are also growing some sister database. As you can see, the logos are fairly similar. So we have Open Beauty Facts with 54,000 cosmetic products. Open Products Facts, which is a more general database with 27,000 items for now. And the goal to encourage the extension of the life cycle of a product, encourage to reuse, recycle, and buy more responsibly. And we have also open pet food facts with 14,000 pet food products. So, of course, these projects are still beginning. They're not as big as Open Food Facts, but we're working to activate the community around those topics. and the big goal being the same, so making transparency the norm across not only food data but all the consumer products. So thank you very much for your attention. Uh, that's it for the presentation. I think we are good to move in the Q&A session. We have 15 minutes.
You have a document linked by Manon in the chat where you can ask your question, and we can answer your question, of course. Manon and I and the rest of the team can also participate to answer a question in this document. About the historical data, we just have a modest way to compare products through the time, is that on Mirabel tool that I've been talking about earlier, we have the database in 2019 and the database in 2023, I guess, and the daily database. The daily export of the database. So you can compare products with the SQL language with 2 or 3 versions of the database, 3 or 4 versions of the database, 2019, 2023, I guess, and but I can have a look to show it to you. I'm doing it live, so yes. As you can see here, these are the products from today. This is the Mirabel tools, which is not very sexy, okay, but which is very powerful if we want to try very complex queries. So this is the database for now. And then for 2023 and 2021, sorry, not 2019, 2021. So you can build queries to compare this kind of these 3 versions. But the results are not so good because sometimes the data has changed, but not as you expect. Sometimes, for example, data which were in kilograms were transformed into grams, and so the data is the same, but it's just the units have changed, and so sometimes the comparison between these 3 versions are a bit disappointing.
We've got another question. Is there a plan to get other nutritional scores than Nutri-Score, HFSS for the UK, or Guiding Stars in North America?
Yes, we would really like to. Some scores are very easy to achieve. For example, I think in Canada and in the USA, the score, the labels, the health labels, can be computed through thresholds, if my memory is good. So maybe it's not very difficult, and maybe we'll do it if we have some time to do it. But when the project is higher than 5 days, of course, it has to be funded. So when we have resources to do it, funds, or sometimes it can be contributors. We have many contributors who help them also on software development, and sometimes one of them is okay to work on a specific project. So when we have resources, we can, of course, launch this project. But so yes, we definitely would like to compute more scores, but we need to have the resources. Of course, if you can help them to gather resources to achieve some kind of scores, we would be, of course, very, very happy about it.
Manon, maybe we could get the people to actually ask their questions directly.
Yes, of course.
I'd love to see them. Who wants to go first?
No more
If
questions.
if no one else wants to speak, I can. I actually was in a meeting with Stefan yesterday, but I just wanted to specify a question on the nutritional data available. But I think I got a pretty good answer already in the written document. But it was concerning the amount of nutritional attributes that are available. But I can see now that you, based on the ingredient composition, link to the food composition database in France to get the nutrient composition of different products. But does that mean that it's basically all the nutrients that are in the food composition database are also available for most of the food products within the Open Food Facts database?
In fact, it depends, but here you can have a short answer. Where it is, sorry. Yes, in this slide you can see that we are already computing, for example, the Nutri-Score for 1.3 million products. So when we compute the Nutri-Score, we have the nutrients, because we can't compute the Nutri-Score without the nutrients. So that can answer your question. When for 1.3 million products, we have both the nutrients and the category of the product. But for many more products, we have the nutrients, but we still don't have the category. So when we don't have the category, we can't compute the Nutri-Score. It depends when what you are requesting.
Charles,
Yeah.
the question is about the other nutrients, the ones that are not listed on the package, like,
okay.
like the individual fatty acids, the vitamins, the minerals, and so
exactly this.
yeah.
And less on the food categories. Actually, those, I understand that for the Nutri-Score, those are important, but less so in my case. That is of importance, but actually the detailed nutritional composition of vitamins and minerals and fatty acids. And
perhaps as a quick complement on this topic, SQL contains a list of additional nutrients averaged. And you know that the national databases contain more or less nutrient depending on the country. So some countries go very deep in the number of nutrients available. We had some requests in the past for rare diseases like lysine deficiency. And so people will typically need lysine, which is not available in SQL. So that's why Charles mentioned that we are looking at linking more nutrient average databases, so that we can fall back on those estimated nutrients when they are needed. And conversely, on Nutri-Score, we're already using SQL, for instance, for fruits, vegetables, and things where we don't have a nutrition table available.
okay, but everything that is available in SQL is in theory available then also for those 1.3 million products in Open Food Facts.
The key word here is estimated, right? So to estimate the nutrient data, first we need a correct ingredient list. That ingredient list can be in any number of languages. We try to analyze it to identify each individual ingredient. So it works very well in English, in French, in a few other languages. In some other languages, it works. We haven't spent so much time optimizing. Then once we have the list of ingredients, most of the time we don't have the exact percentage. So we need to estimate it. We can estimate it with the nutrients that we know about, etc. So it's a lot of estimations. And then, of course, those food composition databases, they also give estimates. So we don't have complete data on all products for all the world. It's work in progress, right?
Okay, yeah, understandable, but very impressive still. Thank you.
Just on that as well, we're looking at a use case where we need the micronutrient data, and as well as trying to get that data from either ingredients or from users, we're investigating whether we can take product names and infer from the names, the brands, anything listed in that string, basically using that to predict micronutrient data. We'll let you know if there's anything interesting there, but that might work as a third approach to that problem.
Perhaps on predictions, so on machine learning, what we currently do, as was mentioned by Charles before, is that we are able to predict a category from actually even more than the product name. We are using images, product name, any information that we have to predict the category. So it's kind of state of the art, or category prediction is state of the art, and we are really using whatever that's available. However, so if you don't have any ingredients, you could try relying on the category. But as Stefan mentioned, it would be better to use the ingredient list whenever it's available, because it would be obviously more accurate.
This is Hunger Games, which is the interface for our machine learning tool to detect categories. For example, here it's in French. I don't know why. I think I can switch in English. Yes. Sorry.
And you also have a country dashboard if you're looking at targeted impact.
Okay, so for example, this is a detection from Robotov, which is our machine learning tool to detect categories, and contributors just have to confirm yes, no, or skip the products if they are not sure. Don't hesitate if you have other kind of questions.
Chinlo, you had a question, I believe.
Yes, so I arrived a bit late, so maybe you have talked about this already. So, but first of all, thank you very much for make the database open. I have a question about this product category, because I have tried to see some product category, but then because I wanted to compare the product within the same product category, but then I found it's very difficult to, because each product belongs to several categories. So I'm wondering, is there a logic to understanding how this is being classified?
Maybe, Stefan, you can explain how the categories are working in Open Food Facts.
So for categories can be used for a lot of different things. We try to cater to all those uses. That's why we have a taxonomy of categories, like a big tree of categories, and they can go very, very, very deep and very specific. And when you put something very, very specific, like I don't know, soy yogurt with strawberry, then it gets automatically all the parent categories. And some categories actually have multiple parents. Like if you take butter, for instance, it will be in dairy, in fat, in maybe in spreads, etc. So that's
So that means if I get a lot of detail, actually, I was able to trace to the biggest one if I want, right?
Yes, you can. Yeah.
Okay. And then I have another question. So,
We also
because
have
we are trying to see how the score changes over the years, and at this moment we are able to only download, let's say 2021, 2023, 2025. But we were thinking about, is that has a longer series, because you were mentioning about that you are trying to look at historical reformulation of product, right? This is in the so I don't know at this moment, is it possible that we have a snapshot for different years but a longer period?
Yeah, we have snapshots here in the Mirabel tool, but these snapshots are only related to the CSV export. So this is not about all the fields in Open Food Facts, but nearly 200 fields, I guess. So there is all the nutrients, ingredients, and things like that. And you can see here you have free version of the database from 2021, 2023, and this is the today's database. So you can compare this free version, but the feedbacks we get from this is that it's very difficult to compare data, because sometimes the meaning of the data has not changed, but only the units, for example, or you see, and so it's very difficult to compare things. But if you, for example, if you click on products 2021, you'll be able also to download the data in SQLite DB, which is SQL DB, and you'll be able to export it in various formats. And so if you want to try to compare by normalizing some data, for example, normalizing the units and things like that, you could do it. It could be a bit long, but you could do it.
Perhaps an addition on that topic, you have to bear in mind that basically, as years go by, for instance, 2019 products are getting more complete because we're having additional machine learning techniques to extract more information from the photos we had at the time. So you even have a completeness effect that's additional to natural product change. So the thing is, the export Charles is mentioning are like a best effort right now, but we have data since 2012. So obviously we didn't have a foresight to have export every year since 2012. And there's this completeness effect that products from 2012 are now much more complete than they were like 3 years ago. So the right way to solve it would be to actually start again from the images, from the core material, from the history revisions that we have, so that you can grasp as many reformulation as we tracked. Otherwise, the data might not be very compelling, and you might not have enough reformulation to have a statistical significance.
When you are logged in, you can see on every products page the changes history. So everything is recorded. You can see the date, the contributor, even the app he's using, and things like that. So you have all the changes, and you can view each revision of the product, and you can also download this with the API. But for the moment, all these data are per product. You can't extract them for all the products. It would require a much more bigger database, and we still don't have this for the moment. We are trying we are trying to fund this project. So if you have ideas, or if you know that some people, some research groups or organizations are interested, it would be great. This is the project I were talking about here.
Okay, thanks a lot. The other thing is, I'm also curious, do you have the list of ingredients for each product? I mean, the main one, like the one we see, you know, that when they, every label, the product label usually says the ingredient, those, like, I don't know, flour, sugar, all these things.
Yes, because I'm not sure to understand the question, but the ingredients are sorted by the percentage of ingredients. So the main ingredients is the first one. Is
Do
that
you
what
mean
you
the
are?
list of ingredients that we use to analyze the ingredient list? The
Yes.
synonyms? So yes, this is something that we call taxonomies, and those
Okay.
are available. It's a multilingual list with synonyms. So it's a text file. It's also available as JSON. You have to be careful that it's a bit more than having the list of ingredients to be able to analyze it. You have quite a complex system of parsing which uses that list, but then you have pre-processing, post-processing, that if you want to do ingredient analysis, you'll have to go through.
Maybe Stefan can add something about this, because you're the specialist of it.
Yeah, you are displaying the analysis. That's a sample analysis for Nutella, for instance, for the French ingredient list. You can click on the ingredients analysis, and you will see something like that. And you will see that for sucre, for instance, it's French for sugar. We have some properties. We know it's vegan and vegetarian. We know it's we don't have sugar in SQL, but we have white sugar, so we have a proxy to it. So that way we can get the nutrients for sugar, which hopefully is almost 100% sugar. Then we have some estimates for the percentage that we compute. So that's the kind of details that you can get through the API and the database. And like it's something very difficult to do perfectly for all products in all languages. So it's something that we are constantly trying to improve. Like this big list of ingredients, the way we do it is that we don't start from an existing list, like, I don't know, a Foodx2 or some list of foods. We start with what we actually find in those 4 million products. So all the synonyms that they use to describe the ingredients, etc., and then we map those to known ingredients, and we try to do that in all the languages. So it's something that we can definitely improve, especially in other languages than English, French, Spanish, Italian, etc. Help is always welcome. Charlie is showing some details, some documentation that we have on how we do that. Yeah, it's very interesting work.
Typically, if you want to improve support for a given language, you can actually help improve the taxonomies by putting synonyms, by putting, for instance, common words. So it can go a long way in improving the percentage of recognition, and it's really accessible to non-technical, I mean, to scientists, even to undergrad students. And it can make a sizable difference in the accuracy of ingredient recognition. Because we have made a specific effort in European languages, but beyond that, it's a bit more sketchy. Even for German, we are having German is a complex language, so we are having some additional work to do.
Okay, thank you very much.
Well, slightly over time. Maybe it's time to wrap up. If you think of questions over the next few days, feel free to put them in the document. and we can always keep the discussion going. Maybe we can ping the Slack link in the chat so anyone can join the community.
On the document, there's a long list of questions about the green score. Maybe we can, if you put your name, I can get back to you and answer all of those, because it could take a long time to discuss that.
Perfect. Okay,
As a
otherwise,
conclusion-
thank you very much for joining.
Yes, maybe 2 words of conclusion. As a citizen project, we really love to help science and to help scientists. And it's a huge motivation for our contributors all around the world when they know that they are helping scientists. So tell us how we can help you. Tell us about your researches, about what you want to achieve, and we will try, of course, to build with you and to help you. And it's one of our core mission, and we really want to go further and to listen to your suggestion, questions, or proposal.
Thank you, everyone, and have a lovely day.
Thanks a lot.
Thank
Have a
you
good
very
day.
much.
Thank you.